Okay, Rams, welcome back. Now we're going to do your homework video. If you're watching this video, maybe you got stuck. Maybe you just want to know if you got it right. Maybe you weren't really so sure about how we did in class and if you really understood it that well and you just want to hear it and go through it with a little help. And that is okay. That's what these videos are for, okay? All right. So, number one, the soccer coach wants to buy t-shirts for his soccer team. The table below shows the cost of the shirts. Which equation represents the relationship between S and C? All right, so remember, when you are writing an equation, this is your X and your Y, right? You always want it to be Y equals. Because our standards talk about how it's Y equals KX or Y equals X plus C. So Y in this situation is the cost. The cost depends on the number of shirts, okay? So we want it to be C equals. So when we say, how do I get to C? How do I get from here to here each time? Okay, what do I do to the number of shirts to get to C? How do I get from 3 to 24? I multiply by 8, or I could add 21. So that means I could add 21 or multiply by 8. But now when I go to this one, 4 plus 21 is not going to be 32. 4 times 8 is 32. 6 times 8 is 48. 8 times 8 is 64. So every time we are multiplying 8 times the number of shirts. Now what that would mean is that each shirt would be $8. Okay, next. The table below shows the relationship between Sheila and her brother's age. So Sheila's age and her brother's age. Okay, so her brother, this is your X and your Y. You want to start with Y equals. So brother's age equals what? Well, how do I get from Sheila's age to her brother's age? Now, when you're talking about age, it can never be multiplicative. They have to be aging at the same pace. He can't gain 3 years to her gaining 10, right? So you have to gain at the same pace. So anytime that it is talking about their age, it's always additive, okay? So it's what do I do to Sheila's age? What do I do to the S to get to her brother's age? What do I do to S here? So from 5 to 13, what am I going to do? I could add 8. Okay, is 10 plus 8 going to be 18? Yes. Is 12 plus 8 going to be 20? Yes. So every time we're taking Sheila's age and adding 8 to it. So Sheila plus 8 equals her brother's age. Okay, next, right over here, number 3. The table below shows the relationship between the number of miles driven and the amount of gasoline used by Mr. Wiley's car. Okay, which description best represents the information in the table? So we want to know about this information here, okay? Let's see, this is talking about miles per gallon, miles per gallon, miles per gallon, gallons of gasoline to miles. Okay, so they're all talking about miles and gallons. But when you use the word per, that means we're simplifying to 1. So let's simplify down to 1 gallon of gasoline. Okay, how do I get from 40 to 2? We could divide by 20. Okay, could I use that same rule to get from 80 to 4? Is 80 divided by 20 going to be 4? Yes. 120 divided by 20, is that going to be 6? Yes. So what number divided by 20 gives me 1? Well, 20. This means that you can go 20 miles, you can drive 20 miles in your car and use 1 gallon of gas. Okay, this one says 15 miles per gallon. No. This one says he gets more miles per gallon when he drives more miles. Well, is 280 divided by 20 going to give me 14? Well, 14 times 2 is 28, so that's true. So it doesn't matter that he's driving more miles. He still gets 20 miles per gallon. So more miles does not count. He can drive 20 miles for each gallon of gasoline. That looks true to me. Now let's look at this last one. The ratio of gallons to miles. So gallons to miles is 20 to 1. That means he has to use 20 gallons of gasoline to go 1 mile. Ooh, he's going to use a lot of gas. That's like a whole tank. To go 1 mile, that's like most of you live a mile from school. Can you imagine a whole tank of gas to take you to school each day? It cannot be true. Those are backwards. So it's C. Okay, next. Which expression is not equivalent to the expression 8y minus 5y? Well, they're all y's. This is positive 8 and negative 5. So that's going to give me 3y's. So now I just need to combine each of these and see which one will give me 3y's, okay? So I'm going to organize it here. 3y plus 5y minus 5y. Well, 3 plus 5 is 8y's minus 5y's. That gives me 3y's. That's true. But I'm looking for the one that's not. Okay, B says 5 times 3y minus 1. Well, 5 times 3y is going to give me 15y's minus 5 times 1 is 5. Oh, that does not look the same to me. Okay, this one over here. Y times 3 is just going to be 3y. Uh-oh, this one's a little different though. Okay, y times 8 minus 5. Well, y times 8 is 8y minus y times 5 is 5y. So 8y's minus 5y's is 3y's. So the one that's not equivalent is B. Okay. All right, so next, the relationship between the number of books checked out at the library on Friday, F, and the number of books checked out on Wednesday, W, is represented by the equation W equals F plus 12. Which description best represents the situation? Now, what I recommend on these is ignore that for a second. Ignore the answers. Let's talk about what this means. Okay, F is the number we got on Friday. And if it's telling me that I have to add 12 to get the number from Wednesday. So let's pick a number. Let's say Friday, somebody checked out 30 books. Okay, I'm going to write this right here. W equals F plus 12. Let's say that on Friday someone checked out 30 books. So it's saying that if I add 12 to it, I get the number of books checked out on Wednesday, which then would be 42. So Wednesday's books are 12 more than Friday's. So now understanding this will help you read these better. The library checked out a total of 12 books on Friday and Wednesday. No, it does not say that at all. The library checked out 12 more books on Wednesday than they did on Friday. Oh, look. Well, based on the number we tried, that's true. The library checked out more books on Monday. Wait. This didn't say Monday in there anywhere. We can't assume anything. The library checked out 12 more books on Friday than Wednesday. Well, no, because to get to Wednesday, we'd have to add 12 to Friday. So that's backwards. So it's G, which would be B when you bubble. Okay, next, Robert is buying a corsage for his date. The relationship between the cost of the corsage and the number of flowers in the corsage is shown below. Which equation represents the relationship between C and F? All right, so it starts with C equals. So it's saying, what do I do to F to get to C? How do I get from here to here? Well, I could add 6. 2 plus 6 is 8, but 3 plus 6 is not 12, so it's not adding 6. I don't see anywhere, any of these that you could just add 4. Okay, so are we going to multiply by 3 or multiply by 4? Well, I see that 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. These all look like they are times 4. So it's 4 times the number of flowers, which would mean $4 per flower, gives you the cost of the corsage. Okay, Janie's Girl Scout troop sold 572 boxes of cookies this week. Last week they sold 36 boxes. Which equation could be used to determine N, how many more cookies were sold this week than last week? Okay, so now N is how many more, right? So what I need to talk about is this week. This week is 572, and last week they sold 36. Okay, so in my mind, to solve it, I know that it would be a subtraction problem, right? So let's look at it as if I'm looking for an addition problem. Uh-oh, it's not a 36. I think it's supposed to be 346. Look at all my answer choices. So I'll fix that there. 346. That sounded way off. Okay, if we wanted to find out how many more I could subtract, right? Well, I could look at it in a couple of ways. I could say, let's check each of these. Then how many more cookies would be 572 minus 346? That sounds good. If I take 346 and subtract, I'm not going to end up with a bigger number unless it's negative, right? If I take 572 and I add a number, there's no way I'm going to get 346 unless I'm adding a negative number. Now, how many more could not be 800 and something here or 900 and something? I should not add this week's and last week's to figure out how much more. Okay, so sometimes just going through and looking at what each answer choice is telling me is going to help here. Oh, we're running out of time. I'm sorry. Okay, Jimmy wrote a problem situation that could be represented by 5m equals 20. Which could be the problem situation that he wrote? Okay, so we're looking for it's a multiplication problem here. So when I read these, think about which one could be solved with division, okay? Mary had a bag of 20 candies. She ate 5. What is M, the number she had left over? No, that is subtraction. Shirts cost $20 at the local discount store. Billy bought 5 shirts. What is the cost of the shirts he bought? Okay, so I would actually multiply there, not divide. Okay, Joan saved $5 more than her sister Laura. Together, they saved 20. What is the amount that Joan saved? Well, that would be addition. Yeah, it's 25. Good job, buddy. Sorry, that's my little 4-year-old there trying to help out. Judy earns $5 an hour doing chores for her mother. 1 week, she earned $20. What is the number of hours that she worked for her mother that week? Oh, I know the total, and I know how much she makes per hour. I would actually have to solve that with division. So let's see if this works. She earns $5 an hour times the number of hours that she works, and she made $20. Okay, there we go. That's an inverse operation helping us again. Okay. Number 9, the table shows the relationship between cups and ounces. Which equation represents the relationship here? So how do I get from here to here? From X to Y every time. Okay, I could add 3.5 on the first one, but not any of the others. Okay, so what am I going to multiply by? Well, I don't want to multiply that first. Let's try a whole number. 1 times 8 is 8. 2 times 8 is 16. Is 1/2 times 8 going to be 4? Well, yeah, 1/2 of 8 is 4. Okay, 1.5 times 8 is 12. Well, yeah, because 1 times 8 is 8, and 1/2 of 8 is 4, and add them together. So it is multiplying by 8. 8 times X. Okay, next one. I'm sorry, we're running out of time. YouTube is going to cut me off here. There are 3 vertices. Which one represents point Z? Basically, we have a rectangle here, and I know on a rectangle I have right angles, so my point is going to be right here. What point is that? Well, I'm over 1.5, and I'm up 8, because I know in a rectangle I have straight lines that have right angles, okay? So over 1.5, up 8.